So this is the second part of this lesson looking at adding and subtracting rational expressions, which was introduced last lesson, and kind of the details of this lesson were also introduced last lesson at the very end. So, but essentially the idea is the same as the last lesson. In fact, right here, if you look, I see two expressions, and for each I want to simplify them, if possible, stating in restrictions. So let's look at this one here. So again, if I want to subtract or add any rational expressions, I'm subtracting here clearly. I need to have a common denominator. I already do have something in common. If you look at the factors, I already have a factor of x plus 4 in common. But other than that, each of these expressions is a different other factor. So if I want everything to be the same, the only way I can really, or the simplest way I can do that, is to multiply this expression on the left by x minus 1 in the numerator and the denominator, and this expression on the right, x plus 1. If you were ever unsure, and it's good to be unsure, if you're ever unsure, just pause and just look and see, do you have the exact same factors in your denominator? The order doesn't matter, but do you have the same factors? If you don't, you made a mistake. If you do, you're right. And I can see I have the same factors. And so now I can look at my numerator. I have x minus 1 times x minus 2 times x plus 1. So that's all my numerator. And yeah, my denominator has a lot of factors. And probably the most annoying thing will be just writing these out every time. Okay, so now I've put these two rational expressions into a single one. Let's just see if I can clean this up at all. Let's see if something simplifies. So distribute the x here, distribute the minus 2 here. And again, these same three factors. And when I combine like terms, I get this polynomial, x squared minus 3x minus 2. And so I might be done. Again, I've definitely cleaned it up from before, but can I simplify this any further? If I look at my numerator in its simplest form, let's see if I can factor it. Because if I can factor it, there may be a factor that cancels out with one of the factors in the denominator. And if I can factor this, I should be able to tell quite quickly. I should find two numbers that multiply to negative 2 but add to negative 3. And that does not factor. For example, you may think of like negative 2 and negative 1, which do add to negative 3, but negative 2 times negative 1 equals positive 2, not negative 2. And again, with a little bit of trial and error, you realize nothing else works. And so nothing works, I mean, in terms of factoring, which means this cannot be simplified. There will be no factors that cancel out. And that's how we simplify things. We cancel out a factor from the numerator and the denominator. All I should do now is state it in restrictions. And I can see from my final answer that x cannot equal plus or minus 1 or negative 4. All right, so that's it for this original question here. If I look at all the work, yeah, I had a number of little steps, but familiar steps. I'm distributing, I'm collecting like terms, I'm seeing if I can factor, but there's a lot of them. The only difference with the expression on the right really is that my denominators aren't yet factored. And so if I look here and here, it's hard to tell what I need to find to create a lowest common denominator until I first try factoring something. And again, x squared minus 1, I'm hoping you realize that's a difference of squares. And when I write that as it's in its factors, then it becomes more obvious, I hope, about how to create that common denominator. Because if you notice, both these denominators already have a factor of x plus 1 in common. And so all I have to do to make the two denominators identical is to multiply just the expression on the right by x minus 1. But whatever you do to the numerator, you have to do to the denominator. Otherwise, you just change the expression. All right, so now I found my common denominator, x plus 1, x minus 1. And my numerator, I have 4 plus 3 times x minus 1. Which, just to speed things up a bit, I'm going to distribute to 3, and so 4 plus 3x minus 3. So combining like terms, I have 3x plus 1 in my numerator. I have x plus 1 times x minus 1 in my denominator. My numerator can't be factored, my denominator already is, none of the factors are the same. They're similar. I mean, there's x plus 1 in the denominator and 3x plus 1 in the numerator, but they're not the same. So I can't cancel this. I can't cancel anything out. Just take the restrictions. I put x. I just realized the question. Oh, yeah, it's x, yeah. So x cannot equal plus or minus 1. So again, I personally wouldn't consider any of this difficult, as just perhaps tedious and frustrating if you don't have an attention for if you are not looking for those little details. And it's frustrating because if we make a mistake with our distributing at some point, or we make a mistake with our factoring, we will never get the right answer. But all of those things aren't inherently abstract compared to other things we'll see in this course. There's a lot of little steps, and it's a process. This is really, compared to so many things in this course, this is really, these are really lessons that that cliche that practice makes perfect really is true. It takes a lot of practice. But there's other concepts that it's not a matter of practice. In my opinion, the hardest things aren't a matter of just practicing and getting better. The hardest things are concepts that are just hard to think about. They're hard to understand. They're hard to connect. This is just kind of tedious, but it is important. Hence, we start with this. All right. So, same idea here. I don't have the same denominators. Let's see if I can, that's not a highlighter. Let's see if I can find my common denominators. So I'll factor each of my denominators. The good thing is they're pretty pleasant trinomials. I can do them quite quickly. The expression on the left should factor the x plus 3, x minus 2. And the expression on the right, the denominator should factor the x plus 3 and x plus 1, with x minus 2 in the numerator. And so notice I can now see they both have a factor of x plus 3 in common. That's good. That gives me less work. But they also have another factor that the other doesn't have. So to make this all balance out, I have to multiply the left side by x plus 1, numerator and denominator, and the right by x minus 2, numerator and denominator. OK, so now I got my common denominator. And really, unless in the end I find that something in the numerator, after I factor it, after I collect like terms, well, actually after I distribute everything, collect like terms, and factor it, if only then there's a factor that is the same as in the denominator, only then would something change my denominator. But until then, or if that, my denominator will just be these same three factors. So in the numerator, let's build on the things we've learned in previous lessons. X plus 1 times x minus 1. I can just do that in my head because that's a difference of squares. I know that must be x squared minus 1. Minus, got to be a little careful here, x minus 2 times x minus 2. That's a perfect square. So without actually foiling it, I know the first term is going to be x squared. I know the last term is going to be positive 4. I know the middle term is going to be x times negative 2 times 2. So negative 4x. That said, I'm subtracting all that, so those brackets are really important. So now let's get rid of these brackets, or distribute the negative, however you want to look at it. And I can definitely cancel out an x squared. Nothing else cancels out, although I do have a couple like terms here, x, the minus 1, the minus 4. So my denominator, I have 4x minus 5, and my denominator have these same three factors, none of which are the same as the numerator, which is good. That means I am done. There's my simplified answer. And what are my restrictions? X cannot equal negative 1, positive 2, negative 3. Keep in mind, let's say there was a little change. Let's say this numerator, instead of 4x minus 5, was 4x minus 8. Then, if that was the case, I could factor the numerator, take out a factor of 4. I'd have 4 times x minus 2 in my numerator. And then I could cancel out the x minus 2 with that x minus 2 there. But that wasn't the case, so let's just put it back to how it was. All right, so one last example before applied problem and the final problem. Something like this we call a complex fraction because it looks complex. But essentially we have fractions inside fractions. And anytime you see a fraction inside a fraction, whether it's like this or even just like 1/2 over 1/5, I don't know, it never has to be expressed like this. This is the same as a single rational expression with something in the numerator and one thing in the denominator. Anytime we see something like this, there's always a way of simplifying it down. So this is definitely not in simplest form. The one thing I think is a very useful thing to do at first is to go back to some key ideas from late elementary school or grade 8 around then, is to realize I'm dividing two expressions here. I've yellow divided by blue, okay? And anytime you divide, it's the same as multiplying by the reciprocal. So that's my sort of plan for the first few steps. First, let me write this as a division statement. 1 plus 1 over x divided by x minus 1 over x. Okay, now I got to be careful though, because dividing by any value, same as multiplying by the reciprocal. But what's the reciprocal of x minus 1 over x? Well, if you want to leave it like this, the reciprocal of x minus 1 over x is 1 over x minus 1 over x. That's pretty ugly. Let's not go there. But reciprocal can be pretty pleasant if I first find a common denominator for these expressions that I've highlighted in yellow and blue. So let's look at these kind of separately. Let's find my common denominator here. Right now there's a 1, change it to an x. That's pretty nice. Change this to an x. And I can now see what's in yellow is equivalent to x plus 1 over x. Let's look what I have in blue. Same idea. Find a common denominator. Right now it's a 1. Make it an x, so it times this by x as well. So I have x times x, so I have x squared minus 1 in the numerator over x. So why is this kind of pleasant? Because now, changing that division statement into a multiplication statement, I'll just put a dot, is quite pleasant because the reciprocal of this, now that's just a single fraction, is quite pleasant. I just flip it over. So it's x over x squared minus 1. And now this question is going to start to come together quite nicely. The hardest part is definitely done, and I've done a fair amount of steps already. I took something that was, looked pretty messy, and I've now got it down to here, okay, which I think looks far, far more pleasant. I am multiplying fractions, so I don't even need to find a common denominator. However, I do notice in this denominator right here, that's a difference of squares. And if I write that in factored form, I can see that I can cancel something out before I multiply anything. And so I can see I have a factor of x plus 1 in the numerator here, x plus 1 in the denominator down there. Those cancel out. I also have a factor of x up here and a factor of x down here. Anything divided by itself is 1. So in the end, when the dust settles, what's left? Well, in my numerator, I just have 1 times 1, or 1. In my denominator, I just have x minus 1. Which means, again, if you look back at all this work, this whole very, very messy, complex-looking expression in the beginning is equivalent to just 1 over x minus 1, which is significantly simpler. That's sort of one of my restrictions. Again, since I did cancel out, I didn't simplify my expression, I probably need to look at this step right here, and I can look at my denominators, and I can see if x is 0, 1, or negative 1. At some point I'm dividing by 0. That means x cannot equal 0 plus or minus 1. Now, compare this to the first review lesson of the course. The algebraic intensity and a kind of a need for attention to detail is far, far higher than what we did at the beginning, which makes sense. We're near the end of this unit. But the actual individual concepts, there's nothing actually new here. If you look at all the steps here, knowing that a fraction is the same as a division statement, knowing how to find common denominators, knowing that you can divide divisions equivalent to multiplying by the reciprocal, how to cancel out factors, all these individual steps, there's nothing new. But yeah, we're combining all these concepts together in perhaps a new feeling way. So the final problem is a kind of common type of applied problem. There's not a lot of applied problems for these sections. Honestly, in my opinion, the most important part of this unit is developing a feeling and a sort of proficiency just with algebraic work, because these are skills we'll use a lot. But this is an example of one sort of word problem here. So you're running a marathon, which is 42 kilometers. You jog the first 22 kilometers at a constant speed, but then you slow down by 2 kilometers an hour for the last portion. So my question is, write a simplified algebraic expression for the total time it took you to complete the marathon. And was there a second part? No, that's it. So first, a little key thing to remember, some sort of basic physics, I guess. That distance is always the same as speed or velocity times time. And so we often write d equals vt. And this can be rearranged in any way, and I'm sure this sounds familiar. So I can solve for any of these variables. So for example, if I divide both sides by v right here, I can rearrange this expression and say time equals d over v. And again, this is definitely part of science courses. It's definitely come up in previous math courses. So all I'm hoping is this sounds familiar. So if we're speaking about distance, speed, and time, or velocity, speed and time, velocity, time, and distance, you know this expression or this equation, d equals vt, or any variation of it, and the one I'm going to use is time equals distance over velocity, is always true. So how am I going to use this? Write a simplified algebraic expression for the total time it took you to complete the marathon. So I'm looking for the total time. How long did it take me to run this marathon? Well, that's why I isolated the t here, because in the end we're trying to think about time. And time is the same as distance over velocity. So what do we know about this? We know the marathon is 42 kilometers, but we ran it in two different speeds. The first 22 kilometers were at a constant speed. I don't actually tell you the speed. So what's the speed? I don't know. We could call it x. We could call it v. I'm going to call it v for velocity. But I don't actually tell you the speed. I then tell you that after the first 22 kilometers, you slow down by 2 kilometers an hour for the last portion. And that last portion is the remainder of the marathon, which must be 20 kilometers, by looking at the fact that the whole marathon is 42. And so, although this is one race, it was kind of completed in two chunks. The first 22 kilometers and the last 20 kilometers. Right? And all that together is our race, 22 kilometers plus 20 kilometers. So let's think about the first 22. The time it took you was the distance, which we know is 22, divided by the velocity, which, again, we don't know, so v. What about the last 20 kilometers? Well, the time it took us for that was the distance, 20, divided by the velocity. We don't know what it is, but we know it was 2 kilometers shorter than before. So it's v minus 2. And so that's the time for each of these parts. And so if I want to find the total time, I want to add this expression plus this expression. That'll tell me the total time for the race. And if I just know how quick my initial pace was, I can find the total time it took. So let's see, it's going to be 22 over v plus 20 over v minus 2. That's the total time. That's it. Let's simplify this. Let's find a common denominator. In this case, both my denominators are different. And so I want to multiply this denominator by, not x, v, the numerator and the denominator. Multiply this by just v. I have my common denominator. I'm doing this fairly quickly now because honestly at this point, this question is not as difficult as the previous questions at all. The algebraic work here is significantly simpler now than the previous questions, so I think I can do it fairly fast. And up here I have 22 times v minus 2 plus 20v. And then combine like terms. And what do we have here? I have 44v minus 44 over v times v minus 2. I will say my numerator, I can take out a factor of 44. I get v minus 1, but still nothing cancels out. So I'm just going to erase that because it's not, nothing canceled out. I didn't need to factor it. And again, honestly, once I got to this step right here, I kind of stopped caring about the question because at this point, I'm just repeating things we've done before. What made this question kind of novel, potentially, was getting to this point right here. There we go. And I'm done.